All right, so homework 6 is telling you to compare the means without doing any calculation. You could take this picture here and we have 1, 2, 3, 4, 5s, a 7, a 10, 2 11s, and a 12. And I could add all that up and figure out what my mean is. But they want you to do it by doing the without doing the calculation. Want you to order them. The mean of A, the mean of B, the mean of C, the mean of D. Those little subscripts tell you which mean you're going to do. So we're going to put them in order from smallest to largest. So when I'm looking at the mean is the average. I start looking at the higher numbers first. If I have more higher numbers, my mean is going to be bigger, right? Oops, still trying to find homework 6 in that file. So it should be chapter 3. At the end of chapter 3 should be your homework pages. Yep, right there. Okay, see, did you jump by it already? Yep, of course. Should be in that packet there. All right, so if I look at those, which one of them would have the biggest numbers? The most biggest numbers. That all really good at English, evidently. A, B, C, or D? B, exactly. Because look at here, B has 2 12s, an 11, and a 10 on my this end, right? This one only has 1 12, that one only has 1 12, that one only has 1 12. So B is going to have the highest mean because it has the most numbers that are bigger than the rest. So I'm going to put that first. I like to do that one first. So B is. So now if I'm looking at the 3 that are left, which one now would have the most big numbers? The A would, right? On the A, we have a 12, 2 11s, and a 10. On these ones, we only have a 12, 2 11s, and no 10s, right? So A would be my next bigger one. I'm working my way backwards. So now I got to figure out on C and D. So these two things are the same, right? Then we have an 8 and a 7 on both of them, so that section's the same. And then this one has 3 5s, but this one has 4 5s. Well, 4 5s is going to be bigger than 3 5s, right? So the C is going to be the next biggest one, and the D is going to have my smallest mean. Okay? So, we look at number 2 again. It's going to have us do the same thing. We're just going to compare the means by looking at them and trying to decide. I like to go from biggest to smallest. You could go the other way if you really wanted to. But if I look at this one, which one here do you think would have the biggest mean? D is going to, because here we have a 12 and 11. Here we just have a 12, a 12, and a 12. So D would have the biggest mean because I have the biggest numbers there on my end. So we got D narrowed out. We did that one. Now if I go with the next bigger one. So if I look at my next bigger one, C. If I look here, they all have 2 9s. And so then if I look here, I've got a 6 and a 5. Here I just have a 6 but no 5. Here I have a 6 but no 5. So since this one has a 6 and a 5, that's going to be the next bigger one, right? Working my way down, the next one. Which one? A. So on A, I have a 4 and a 3, but here I have a 4 but no 3, so that's going to be bigger. And so, of course, last I'm going to have my B. So B, A, C, D would be the right order for those. All right. While I'm moving the board, think about the next one. Here we go. So on the next one, we have our 4 distributions. Which one is going to be the biggest one? C is going to be the biggest one. We have two 12s here. All the rest of them only have 1 12. So since that one has 2 12s, we know C is the biggest one. The next one would be the D. We have a 12 and 2 11s, 12 and 1 11, 12 and 1 11. So we know that 12 and 2 11s would be bigger. So D. And then the next one, B. And then, of course, the smallest one is going to end up being our A, right? So that's how we can compare the means without having to do any calculations. The bigger the numbers we have, the higher the mean or the average it will be. The next one, we are doing what's called a box and whiskers plot. When we do a box and whiskers plot, the first thing we have to do is get our data in order. So either in Excel or on your graphing calculator, we want to sort our data. So, whichever one you prefer, type all those numbers in. Just to make this go a little faster, why don't a couple of you do number 4 and then the other 2 do number 5 and we'll let Anton do number 6. He has to do it by himself. That way we won't have to wait and sort on every one of them.
So we got one, number 1?
So you get to do number 1, yep. And while they're doing number 1, you 2 can do number 2 and that way, or number 5 actually. And that way when we get to that one, they'll be all sorted and we'll let Anton sort number 6 for us so that when we get to number 6, it'll be ready to go. And we won't have to wait forever. So, remember how to get them in your list and get your list sorted in order. We'll have lots of practice with that. Okay, so give me your numbers in order for number 4 here. Fifty-two,
57,
57,
58,
8,
64, 64, 66, 67, 68, 70, 75, 75, 76, 78, 79, 80, and 83.
I wrote too big. Once I have my list in order, I'm going to separate them into, first of all, half, and then into quarters to do my box and whisker plot. So in this one we have, how many numbers on our list? Does it tell us or do we have to count? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 numbers on our list, right? So if I have 16 numbers on my list, halfway would be between 8 and 9, right? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So that point right there is my median or my middle of my thing, right? Now I got to divide it up into quarters. So if I divide that up into quarters, I have 1, 2, 3, 4, 5, 6, 7, 8 on each side, so I can divide it up into 4 and 4, right? Now what I want to do is find the average since that split halfway between. If I would have had an odd number, I would have had a value right in the middle and I would have hit that value, but we have to average. In this case, the average is 64 and 64, well, that's going to be 64, right? Over here, if I have 68 and 70, the average of that would be 69, right? Halfway between 68 and 70 would be 69. If you're not sure, add them together and divide by 2. Over here, we want to be halfway between 76 and 78. 77. So, once we found those points, we are now going to make what's called the box and whiskers plot. My whiskers are my two end values, my smallest number and my biggest number. So 52 is going to be somewhere down here, and 83 is going to be somewhere over here. In between that, I'm going to have my box. My box is my range from my first quartile to my third quartile here. And so I'm just going to make my box in the middle somewhere. It probably should be drawn a little straighter, but okay. This mark right here should be at 64. And they're just going to have a little line that connects that. That's the whisker. This one over here is going to be at my 77. See, if I drew it closer, it would be more to scale. Because the distance between here and there would, yeah, they'd probably be all right. And then my median, my middle, is just going to have a little line here, and that's going to be a 69. And so my box and whiskers chart is going to look something like that. Of course, you guys are probably better at art than I ever was, and so your drawing probably looks prettier than mine. So my two end points, and then my first quartile, my median, and my last quartile for my box. You know when you got that sketched out, so I can move the board.
I have a question. So, this and this is for.
Yep. This is the average of these two numbers. This is the average of those two numbers. And that is the average of these two numbers. That should be a 77. Did I write 79? No, I wrote 77. That's supposed to be a 77.
Why is this up here? Or is this just the average of this one?
That was the average of that one. That was my scribbling.
So 69 is the median of 52 and 83?
It's the median of this list of values. It's not the mean, it's the median. It's the middle value.
Okay, so that's why it goes in the middle.
That's why it goes in the middle. And 69 is closer to 64, so that bar should be closer to the 64 end than to the 77 end, if I would draw it properly. You're going to have a little slidey thing. You'll see when you put it in there. It'll look prettier than mine. All right, so my sorters for number 5. You want to give me your numbers in order there for number 5?
24.
Who's going to read and the other one's going to verify? Moretta? 29?
No,
Oop,
25.
25.
27. 32. 32. 40. 40. 42. 43. 44. 47. 47. 48. 52. 52. 53. 60. 61.
I got them all smushed in there. All right. How many numbers well, I can tell. We have 18 numbers on our list. This one told me. They were nice. 18 numbers on our list. So if I want to split that in half, I'm going to have 9 and 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I want to split them into quarters. So if I divide this in half, since I have 9 numbers, my middle one is going to be 1, 2, 3, 4, 5, the 32. I don't have to average that one because it's right in the middle. I don't have to average the two values. Over here, 1, 2, 3, 4, 5, 52 is going to be the middle one on that list. So the only one I have to find the average of is my median here. Average of 43 and 44, I would be halfway between those. I would have 43.5, right? If you're not sure, add them together and divide by 2. Find the average of those two numbers. So, making my box and whiskers, my starting value going to be at 24. My ending value going to be at 61. My box is going to be somewhere in the middle of that. I should actually probably draw it closer to whatever end it should be, but I'm going to just stick it in the middle. 32 was my first quartile. So I'm going to make my line there. My median was at 43.5. Let's see, this one was at 52, 43.5. That'd be a little closer to 52. We'll just say it's about there. Finish my little whisker there. And it's going to look something sort of like that when I'm done. So when it says divided up into quartiles, they're talking about into fourths, right? They'll also talk about the inner quartile range, which will be from here to here, if you've read your chapter 3. If not, you're going to read that for next week, right? Number 6. Anton, you were in charge of that one. 27. 28. Whoops, if I could write, I'd make it 28.
29, 31, 32, 33, 37, 39, 40, 41, 42, 43, 44, 45, 45, 49, 50, 52, 53, and that's it.
Man, that's fast. I hope I got all those written down right. We'll find out. All right, so on this list we have 19. So if I'm going to do 19, the middle, the median value would be which one? The 9th one, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. Whoops, nope, that's not right, unless I don't have my numbers written down right. 19, half of 19.
Yeah, there's 19.
7, 8. 15, 16, 17, 18, 19. We gotta go 10. Half of 19 would be 9.5, right? Now I erased that number. What was that number?
40.
40? I grabbed a different color. Half of 19 would be 9.5, so I've got to go up to 10. Right? I'd have 9 on each side then. Now if I double check that. 1, 2, 3, 4, 5, 6, 7, 8, 9 on that side. 1, 2, 3, 4, 5, 6, 7, 8, 9 on that side. Now it looks like I'm on the middle one. So 41 is going to be I look at number 6, number 7, number 5, and then I won't put that different now. Okay, so now I have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. So the middle one would be 1, 2, 3, 4. The 5th one, right? 1, 2, 3, 4. I've got 4 on each side. So half of 9 is 4.5. So 5, the 5th one is going to be in the middle. On the other side, same thing. I have 9, so 1, 2, 3, 4, 5 should split that in half so that I have 4 on each side of that. So my starting number is going to be my 27. My ending number is going to be my 53. My box is going to be somewhere in the middle of that. My first quartile starts at 32. My median is at 41. And my next quartile is at 45. And see, I drew my 41 closer to my 45, then it would look more like it should. Now, we are going to do a box and whiskers plot on our graphing calculator. We're going to put our list in, list 1. You do not have to sort it, but if you already have it sorted, you're okay. We're going to use the problem we just did, so Anton gets easy because he already put the list in. But the rest of us, we have to put our list in.
On the calculator?
On the calculator, yep. This is on the graphing calculator.
All right.
So we don't have to sort it, we just have to put our list in. So if there's something in list 1, highlight list 1, hit clear, and then hit enter to get everything out of list 1. And then we got to put your numbers in. You can put them in, it doesn't have to be in sorted order. You can put it in the original order. If it's already sorted, you're okay too. I'm going to put it in not sorted just for fun. All right, once you have your data in list 1, press second and Y equal to go to the stat plot. If you remember, the stat plot's up there in blue, so we have to hit second function and Y equals. We did stat plot the other day when we did our histogram. This time, we're going to make sure our stat plot is on for the first one. Mine is on because I did my histogram, but if it's not, we need to enter on number 1, turn your stat plot on, and then we're going to highlight the one that looks like the box and whiskers, which is the 1, 2, 3, 4, 5th one over. There's 2 that kind of look like it, but you got to have the one with the bar in the middle, right? So do the box and whisker. Then the X list should be set to list 1 because that's where we put our data. If you put your list in list 2, you'd have to change it to list 2, but we hopefully put it in there. And whatever color you want to do, then or the frequency is 1, then we're going to press the graph button. Oh, I still have my histogram on there. Anybody else still have? Oh, I better clear out whatever else is drawing on there.
Then you put
Second.
graph.
Yep. I must have not hit enter on top of my... No, I didn't. You have to enter on your box and whisker to make sure it's highlighted. Otherwise, it's still trying to do my histogram, which I didn't want. You just hit second function and stat plot again.
Is this
So
right?
second function Y equal. Now mine's cut off because my window needs to be changed. We're going to fix that in a second.
Is that?
Oh, let's see. We don't see anything on yours. Let's hit second function and stat plot for me. Whoops, that didn't go. Let's try that again. There we go. That is on, and it's on that, and you're doing list 1, so that all looks good. Your list. Your list looks like you got your list in there. Okay, it must just be a window issue. So let's change our window so things fit nice. I'm going to hit window on mine. My X minimum, let's put our X minimum at 25 so that it's not right in the end, but it's somewhere close. So 25 sounds good. Our X maximum, let's go to 55 so that our thing fits in there. Our scale, well, let's just use 5. That sounds good.
Where did you get those numbers?
Oh,
Anyway,
where did I get which numbers? To get to the window? On the window to change your scale? Where did I pick them out from? Because I just wanted this to fit on there because we're redoing this one. And so if I pick something smaller than 27, it's not going to cut my graph off. So I just picked 25 because it sounded good. I could have put 20 or 10 or something smaller, but that way it fits my screen.
so you're supposed to enter your graph?
You may need to change your Y. Your Y minimum, you could put 0, or I have a -1 in there. It probably doesn't make a whole lot of difference as long as your graph fits from top to bottom, which I think yours was.
What did you
And
say for X minimum?
X minimum, I put 25 in. Anything less than 27 probably is good. And then if you hit graph, it might look something like that on your screen. Is yours showing up yet?
Yeah.
Yep.
It's possible.
Okay, yep, that looks good.
Oh.
It looks good. Okay, so now it tells us here we can use the trace function again to see the data like we did the trace function with our histogram. If you hit trace, right now it's showing on the bottom my median is 42, right? Ooh, I must have typed something in wrong. Ignore me, it should be 41. If you typed in right, you should have a 41 there. I was trying to go too fast. If I hit my arrow keys, I can move over onto my quartiles and on the ends of my whiskers and see if my numbers match up like they should. So the very end number, when I have that highlighted, it should say 27. I got that one right. The next one says 32. The next one should say 41, and then 45 and 53.
No numbers showed up online.
They show up on the bottom. Oh, wait a minute. Okay, did you hit trace first? Did you hit trace up here? There we go. See that down there now?
Okay.
The median is 41, which that's what we got. And then if you arrow over, the beginning we said was at 27, the first line there, 32, and so forth.
Oh.
So that if you use this to sort your data to draw your box and whiskers, you could double check it on here to make sure you got the same answers as you did when you figured it out by hand, right? So that's how you do a box and whiskers on your graphing calculator, the stat plot, same way you did your histogram. You might want to do second function and turn your stat plot off, just in case you use it for something else later. So if you hit number 1, highlight the word off and hit enter, then it should be off. And then if you hit second function and mode, that's the quit that takes you back out to your home page so that you don't have to worry about what might else be on your screen. And, oh, I suppose I have to clear my writing. Do I have a pen off? No, this doesn't want to behave. All right. The next thing. The next ones are rejecting unreasonable claims based on average statistics. So basically they want you to read these to see if they would be a reasonable thing or not, or did somebody just try to trick you with their statistics. It says a private college advertised that last year their freshman students on average had a score of 1,160 on the college entrance exam. Assuming that the average refers to the mean, which is the following claims must be true based on this information. More than one statement could be true. If none of the statements is true, mark the appropriate box that says none of the statements is true. So, knowing that the average score was 1,160, can we say that next year some of the freshman students will have a score of at least 1,160? Do you know that for sure, or is that just a guess? It's just a guess. So we can't say that's true. That's just somebody guessing that they're going to. Just because this year they did, doesn't mean next year it's going to happen, right? Last year, at least one of the freshman students had a score of exactly 1,160. Do we know that for sure, or is that just a guess? Do we know that somebody had exactly 1,160 just because the mean was 1,160? No, we don't, right? Somebody might have had that score, but we don't know that. The mean is just the average, so that doesn't mean somebody had exactly that. So that one is not true for sure. So we can't say that's true. Last year, some of the freshman students had a score of less than 1,000 on the exam. Do we know that for sure? Or is that just a guess? Anton's shaking his head no. No, we don't know that, right? We don't know where the end score was, if it was at 1,000 or not. We know that we had to have some that were less than this number, but not necessarily less than that number. Last year, all of the freshman students had a score of 1,160 or above. If I know my average was 1,160, did everybody have that score or above? No, somebody had to have less than that for the average to turn out to that, right? So nope, that one's not true either. They give us all not trues, by the way, on this one. Last year, the number of freshman students who had a score of more than 1,160 on the exam was equal to the number of freshman students who had a score of less than 1,160. So just because I have a mean of 1,160 doesn't mean that I have an equal number on each side. That would be true if it was the median, but not of the mean, right? So on this one, none of these things are actually true, just because I know what the mean is. They're all just made up things. The next one will have something that's true at least. So on number 8, a job placement agency advertised that last year its clients on average had a starting salary of $40,000. Assuming that the average refers to the mean, which of the following claims must be true based on that information? So last year, all of the clients had a starting salary of $40,000 or more. True or false? False, right? If my mean is 40,000, that doesn't mean everybody has 40,000. Last year, fewer than half of my clients had a starting salary of 40,000 or less. False. Again, we can't say that it's exactly half. If it's the average, it doesn't mean it's half. If it was median, we could maybe say that. This year, some of the clients will have a starting salary of at least $40,000. Can we say that one's true? If that said last year we could, but it says this year, right? So we cannot make any predictions about what's going to happen this year based on last year's average. So if it says this year, we can't say that's true because we don't know what's happening this year. The next one, last year, some of the clients had a starting salary of more than $36,000. If my average was $40,000, do some of them have more than $36,000? Yeah, they'd have to, right? So that is the only true one based on what we know from last year. Anytime they say this year and they're referring to last year, we know that one's not going to work. But here, if we know it has to be at least 40,000, some of them had to have more than 36,000. Number 9. Assuming an investment company advertised that last year its clients on average made a profit of 7%. Assuming that average refers to mean, which of the following claims must be true based on this information? So, last year, some of the clients made a profit of more than 4%. That's true. Since we know the average was 7% last year, we know that some people have to make more than 4%. Otherwise, the average couldn't be at 7%. Last year, at least one of the clients made a profit of exactly 7%. Can we say that for sure? No, we can't. Watch for that. Whenever it says exactly, you don't know what the exact numbers are. You only know what the median or the mean is, right? So if it says exactly, it's probably not true. Last year, at least one of the clients made a profit of less than 7%. That would be true, right? My average is 7%, so at least one person had to have less than 7%. Probably more than one had less than 7%, but at least one did. Last year, the number of clients who made a profit of less than 7% was equal to the number of clients who made a profit that was more than 7%. Can we say the two things are equal just because we know the mean? No, we can't, right? The mean is the average. It doesn't mean it splits it in half. That's the median. So no. This year, some of the clients will make a profit of at least 7%. False. We can't say that's true. We don't know what's going to happen this year. So anytime they say this year and they were talking about last year's statistics, we can't say it's true. We don't know what's going to happen this year. So, the only true ones based on knowing that the mean was 7% last year are the first one and the third one. Weighted mean. If we're going to do a weighted mean, it means that we have more than one thing in each category. So basically the first thing we're going to do is just multiply 7 employees times the 750 to find the total amount for those people, 7 times the 850 for the total here, 11 times the 925 for the total here. We're then going to find the average of those. So 7 times $7.50 would give you 52.5, right? 7 times my 850. 59.5 or 59.50 if you're writing money. And then 11 times $9.25. 101.75. We're going to add those values together. So go ahead and add those up for me. $213.75. Now that is the sum you would get if you took 750 plus 750 plus 757 of them and so forth. We really have a total of 25 employees. So if this is the total amount that they made for their hour, or their total for their hourly wage, and we had 25 employees and we want to find the mean or the average, we are going to take our $213.75, divide it by our 25 employees. That will give us the average pay for the employees per hour anyway. We are going to round our answer to 2 decimal places. And so if you divide that out and round that off to at least 2 decimal places, you would have 8.55. In other words, the average hourly wage would be $8.55. Okay? So on number 11, same kind of thing. I'm finding the weighted mean. First thing I'm going to do is multiply each of the numbers times, in this case, numbers again, the number of household times the number of children. So 3 times 4 would give me, you all yell 12. 16 times 2, 32. 15 times 3, 45. And 4 times 6, 24. So I'm going to multiply that out and add all those numbers up. You got what? 113. There we go. 113. We're going to take that total of 113 divided by the total number of households that we had. In this case, it tells us 38. If they didn't tell us the number of households, we'd have to add those together, but I think most of the time they're nice and tell you what that number is. 113 divided by 38. We are rounding this one to 1 decimal place, it says. So they changed that on us. If you go farther than 1, you're okay because it says at least 1. And so if I round that off, I would get 3.0, did you say?
Yeah.
3.0. Okay? So number 12, same thing. We're finding the weighted mean. And so we're first of all going to start by doing all of our multiplying. 3 times 3 is 9. 4 times 2, 8. 9 times 5, 45. You already did that, right? You added that up and you got 62. We're going to take our 62 and divide it by 16 families. And this one we're doing at least 1 decimal place again. And so we would round that off to 3.9. Exactly. 3.9. Okay, not so bad. The next ones. I hate these ones where you don't do calculations. I'd much rather do calculations. Is another estimating one. We're going to estimate the standard deviation without calculations. Standard deviation is how far it gets from the middle, right? The deviation is how far away it is. So when I'm estimating the standard deviation, I'm looking for how far, or which one's the farthest from the middle, closest to the middle if I'm going to the other end. But I'm thinking about where I am to the middle. So if I look at those 3 things, which one has the values that are farthest from the middle? I always, for some reason, like to work my way backwards. B would be farthest from the middle, right? My middle would be here at 6. This one goes from 3 to 9. This one goes from 4 to 8. And this one goes from 4 to 8. So 3 to 9 would be farther from the middle, right? So that's going to be my biggest one. The B is going to be the last one. So on the next one, they both went from 4 to 8. I want to figure out which one would be, I don't know how I want to word that, the next farthest away from the middle. But here what I'm looking at is, this one only has 2 in the middle. This one or 2. 1 at 5 and 1 at 7. I'll word it that way. This one has 2 at 5 and 2 at 7. So my values are going to end up being closer to the middle because they're more stacked up there in the middle, right? So this one, A, is going to be farther from the middle than the C is. The C is going to be the closest to the middle. It has more values in the middle. So on number 14, if I can find where number 14 went, Again, I'm comparing their standard deviation. Here my middles are going to be at 7. So which one would have the biggest spread that's farthest from the middle? Which one? B. Yep. B would be. This one goes from 1 to 13, 2 to 12, 3 to 11. So 1 to 13, definitely a farther spread. The next bigger one would be C. C went from 2 to 12. A went from 3 to 11, so C is definitely has a farther spread. And then, of course, the A is going to be the one that's going to be closest to the middle. That one was an easier one. Alrighty. Number 15 here. Again, I'm looking for the standard deviation, so the one with the biggest spread that's going to be farthest from the middle is going to be... Which one did you say? B? B. That one went from 3 to 11, that one goes from 4 to 10, and that one goes from 4 to 10, so definitely the 3 to the 11 has the biggest spread. Here we're going to look again at our middle. I might actually do this closer to the middle one first, because here this one has more in the middle than this one does, right? So this one's going to go first, that one's going to go second. So I have the C and then the A. I throw my papers on the floor. So if I have the same spread from 4 to 10 and from 4 to 10, whichever one's closest to the middle is going to be the one that's first, or has more stacked up in the middle. Okay? Estimating the mean of grouped data. So when we estimate the mean of grouped data, basically we're going to find the midpoints of each of our bars of our histogram. And then we're going to do it like we did the weighted mean. So first thing I'm going to do is find my midpoints. Halfway between 0 and 6 would be 3. If you're not sure, add them together and divide by 2. Halfway between 6 and 12 would be 9. Halfway between 12 and 18, 15. Halfway between 18 and 24, 21, right? Halfway between 24 and 30, 27. And again, if you're not sure, just add the two numbers and divide by 2. Now we're going to use the midpoints and we're going to multiply it by each of the values like we did with our weighted mean table. So we're going to take the 3 times the 3, which we know is 9. We're going to take 9 times 9. How did that work out? Which we know is 81. We're going to take 15 times 7. What's 15 times 7? Write that down. Let's see. 5, carry my 3, 105. Did I multiply that right? All right. Then we're going to do our 21 times 5. So that would be 5, 10, 105 again. And then we're going to do our 27 times 3. 3 would be 21, 6, 7, 8, 81 if I multiplied that right. Once we've found all those products again, we're going to add up all that column of numbers. So I'm going to take 9 plus 81 plus 105 plus 105 plus 81. What do I get for my total if I add all those numbers together? 381. We are now going to take that 381 and divide it by the 27 post offices that we had. Almost looks like a 2. So if I take my 381 total, I divide it by the 27 randomly selected post office visits. I would round my answer to at least 1 decimal place, it says. I would come up with, what was that? 14.1. 14.1. So the mean waiting time would be 14.1 minutes. right? The smallest was between 0 and 6. The biggest was between 24 and 30. The average, 14.1 minutes that I have to wait. Ooh. Number 17, same kind of thing. Based on my histogram, I want to estimate what my mean is going to be. So I'm first going to find the midpoints of each of my bars here. So halfway between 0 and 10 would be 5, 15, 25, 35, and 45, right? We are then going to multiply those values by the numbers on the top of our bars that they were so nice to mark for us so that we don't have to try to line it up straight. So first of all, we have 5 times 2, which we know is 10. Then we're going to do 15 times 3, 45. Then we're going to do 25 times 6, 150. And then we're going to do 35 times 9,
315.
315. And last we have 45 times 4, 180. And then we're going to add all of those up. $700. We are then going to take that 700 and divide it by 24 was our sample. 24 households. We are rounding our answer again to at least 1 decimal place as I scribble over the 1 decimal place. So if I divide that out, I would round that off to 29.2. .2% would be my average appreciation value for my house. And the last one, number 18 here. Oh, at least they did 5s and 10s, and that's easy to find the average of. So, again, we have 5, 15, 25, 35, and 45, right? Halfway between each of those. Again, if you're not sure, you can add the 2 numbers and divide by 2 to get that average. So 5 times 5 is 25. Then we're going to do 15 times 9,
135.
135. And then we're going to do 25 times 4, 100. And 35 times 4,
140.
and then last we have 45 times 2.
90.
Then we're going to add all those numbers up. $490. So we want to estimate the mean survival time. We're going to take our 490 and divide it by the 24 patients that were diagnosed, right? We got what? 20.4? 20.4. The mean survival time in months. I want to live longer than that. By the way, if they hadn't given us this number in the word problem, which I think they do on all of them, you could have added these numbers up here, and those numbers should add up to the 24, right? All right, so hopefully nothing too hard at the beginning of Chapter 3. We're not all the way through Chapter 3, but we've started Chapter 3 anyway.